Hello students, so I'm going to teach decoders. Decoder is nothing but which takes n input and generates 2 raised to n outputs. We know when there is n variable Boolean function, it forms 2 raised to n mean terms. As for example, if there is only one input, say x variable, it can have two values 0 and 1. So output, say output is y, will be having two values, x dash and x. Similarly, when the input is two inputs, say x1, x0, two inputs, so it can take four values 0, 0, 0, 1, 1, 0, 1, 1. So these two input must be decoded to these four values. So output we can say y0, y1, y2, y3. y0 must be equal to x1 dash, x0 dash, y1 must be equal to x1 dash, x0, y2 must be equal to x1, x0 dash, and y3 must be equal to x1, x0. So when two inputs are there, it generates four mean terms, and these four mean terms are the outputs of the decoder. So we can very easily write the circuit diagram for the n is to 2 is to n output. So for example, 1 is to 2, 1 is to 2 decoder. What will be the circuit? 1 is to 2 decoder. It's nothing but simple. Input is x, its inverted output is 1, y0, and non-inverted output is y1. So this is the 1 is to 2 decoder, and you can put this into the box. So when x is 0, this is equal to x dash. When x is equal to 1, y1 is equal to x. So at the time, only one input will go high, only one output will go high. So this is 1 is to 2 decoder. Similarly, if you want 2 is to 4 decoder, so we must have two inputs. So inputs say x1 and x0. So from x1 we can create not get, this is x dash, another is x1. Similarly, from x0 we can create, this is x0 dash, another is x0, visible here. So using x0, x1 and x0, we can generate this four input variable. Now to create decoding is nothing to generate the mean terms. So we can generate the mean terms like first mean term must be equal to x1 dash, x0 dash. So here we will connect x1 dash, x0 dash. Another mean term must be x1 dash, x0. So we will connect here x1 dash, x0. Third mean term must be equal to x1, x0 dash. So we will connect similar x1, x0 dash, and fourth mean term must be equal to x1, x0. So mean term must be x1, input must be x1, x0. So this is the decoder output. These four are the output. This is y0, y1, y2, and this is y3. And input we have only these two values, x1 and x2, which must be connected to NOT gate to generate x0, and this 4 is connected to here to generate this multiplexing. Now I'm explaining 3:8 decoder. So 3:8 decoder can be formed by 3 input signals X, Y, Z. Here we are drawing all the X, Y, Z lines and its inverted lines also. So to generate first minterm y0 is equal to x dash, y dash, z dash, we must connect all the inverted input to this x dash, y dash and z dash. Again, to generate second minterm x dash, y dash, z, we must connect to this and get all this x dash, y dash and z. Similarly, we can connect all this input to the AND gate to generate the minterms, and this forms 3:8 decoder. There is very simple difference between decoder and multiplexer. So what should be the multiplexer? If it is 8:1 marks, how to generate 8:1 marks? So circuit is very similar. All this 8 output must be connected to one OR gate, and these data will become the control signal. XYZ becomes control signals, and in addition to this control signal, we must transfer some input data also. So input data say D0 must be transferred to the this AND gate, D1 must be transferred to the this another AND gate, D2 must be transferred to the third AND gate. Likewise, the D7 must be transferred to the input data, D7 must be transferred to the 7th, 8th gate, in addition to all these control signals. So there is very small difference between decoder and multiplexer. So from decoder, we can generate multiplexer by simply adding the 8 data to the giving input as a AND gates, and all the outputs of the AND gate, which are the minterms, must be connected to one OR gate. Will generate the one function f, which is the nothing but the multiplexing output of 8 input data. Thank you.